Graphs session 5. Students, already we studied the graph of the form y equal ax squared plus bx plus c and the graphs of the form y equal x plus a whole thing squared plus b. Finally, let's discuss the graphs of the form y equal x plus a into x plus b. Graph of the form y equal x plus a into x plus b. As in the previous types, let's see what are the characters without drawing the graph by this form. As in the above case, when the function is given in this form, certain characteristics of the graph of the function can be inferred without sketching the graph. Let's see what are the characters can be inferred without drawing the graph. Number one, nature of the graph. And you know, already we learned the nature of the graph is going to be minimum or maximum. So that is depend on the sign here. If the sign is plus, the graph is minimum, and the sign is minus, the graph is maximum. Therefore, the nature of the graph is depend on the sign, or we say the coefficient of the quadratic term. Number two, roots of the function. Especially in this type of graphs, we can determine the roots without drawing the graph, because the graph form is already factorized, x plus a into x plus b. The quadratic equation, when in the factorized form, you know that factors easily can be determined from the pattern of the equation. In this equation, when y becomes 0, we can get the roots x equal minus a and x equal minus b. Therefore, the roots of this function are x equal minus a, x equal minus b. Changing the sign, what is inside the bracket? When y equals 0, we can determine the roots x equal minus a and x equal minus b. So the third one, the points which the function intersects the x-axis. Now the graph is intersects the x-axis. When the graph intersects the x-axis, already we learned the points where the graph cut x-axis is known the roots. So intersecting points, x values are minus a and minus b. Therefore, when you writing the coordinates of the intersecting points with that value of the roots, it's going to be minus a comma 0 and minus b comma 0. That means root comma 0 and the other root comma 0. These are the coordinates of the points where the graph cut x-axis. So the next character is equation of the axis of symmetry. Equation of the axis of symmetry is the line goes through the middle of the graph. Here, according to the second part, the graph cut the x-axis at minus a and minus b. So when the axis of symmetry goes through the middle or the center of the two values minus a and minus b, so we can obtain the equation of the axis of symmetry by adding the two values, divide by 2. Taking minus common, a plus b, the two values added, the two roots added, dividing by 2 to get the middle value, the half of the sum of the two. Let's go for an example to understand more about the characters of this type of graph. The example 1, y equal x minus 3 into x plus 5. Character number 1, nature. Whether the graph is minimum or maximum. And we know the minimum maximum nature is depend on the sign available here. That means that is depend on the coefficient of the quadratic term. Since this example the sign is plus, the nature of the graph is minimum. So the graph with minimum value. Character number 2, values of x when y equals 0. That means roots of the equation or roots of the function. Since here the pattern is already in the factorized form, when y equals 0, the roots are when this minus 3 comes here plus 3, or when plus 5 comes here, that is minus 5. Therefore the roots of the function are 3 or minus 5. 3 or minus 5. Number 3, the points at which the function intersects the x-axis. If the graph is intersects the x-axis at 3 and minus 5, the coordinate of the intersecting points, the x values along with the y value, the answers are minus 5, 0 and 3, 0. So intersecting points minus 5, 0 and 3, 0. Number 4, equation of the axis of symmetry. Already we learned the method of obtaining the equation of the axis of symmetry. Since the intersecting points are 3 and minus 5, add the two values and divide by 2. So therefore equation of the axis of symmetry, adding the two roots and then dividing by 2, we can get it. So axis of symmetry is x equal minus 1. So the nature is depend on the sign, first part. Second, the roots are depend on the values available here inside the bracket. Whether the roots minus 3 here, plus 5, therefore the roots going to be plus 3 and minus 5. The points which the function intersects the x-axis is along with the x values roots, the y values are 0. Finally the equation of the axis of symmetry, by adding the two roots and then divide by 2, we can get the axis of symmetry of the given function. Example number 2, y equal minus x plus 3 into x minus 1. Question number 1, what is the nature of the graph? Here, since the sign is minus, the nature of the graph is going to be, maximum. Therefore, this is a graph with maximum value. Number 2, values of x when y equals 0. That means the roots. So directly we can determine the roots by observing the pattern of the equation. The roots are going to be minus 3 and plus 1. The opposite sign of the values available here. So let's see how to determine the roots. Equalizing 0, and then the roots are minus 3 and plus 1. Question number 3. The points which the function intersects the x-axis. The graph cut x-axis, we know, at the place minus 3 and 1. Therefore, when you are writing the coordinates along with this x value and the y values, the coordinates are minus 3, 0 and 1, 0. Question number 4, equation of the axis of symmetry that can be obtained by adding the two roots and then divide by 2. So equation of the axis of symmetry, adding 1 with minus 3, then divide by 2, answer minus 1. Therefore axis of symmetry is x equal minus 1. Okay, let's draw a graph of the form y equal x plus a into x plus b. The given function here is in that form y equal x plus 1 into x minus 3. Let's prepare the table for that. The values of x from minus 2 to plus 4 and the corresponding y values also shown in the table. According to the table, when we draw the graph, we'll get the graph like this. Let's answer the questions using the graph. Question number 1. Minimum value of the function. Minimum value of the function, it is here minus 4. Therefore, minimum value of the function is minus 4. Question number 2. Coordinates of the minimum point. Coordinate of the minimum point. Here x-axis shows 1. Y-axis value shows minus 4. Therefore, coordinate of the minimum point is 1, minus 4. Question number 3. Equation of the axis of symmetry. When you draw the axis of symmetry, that goes through the value 1 of x-axis. Therefore, equation of the axis of symmetry is x equal 1. Question number 4. Behaviors of y when x is greater than 1 and less than 3. x1 is here. The x value 3 is here. Behaviors of graph between 1 and 3 of x. So between 1 and 3, the specific part of the graph is shown here by blue color. Behaviors of the part shown by the blue color. Let's go through the y-axis. X range is between 1 and 3. According to that value, you can see here the interval values of x. Here minus 4, here 0. So, between the range of minus 4 and 0, what happened to the function? So, here when you go through the nature of the graph, behaviors of the graph is increasing negatively. The graph is, the blue color part shows increasing negatively from here minus 4 to y value 0. Therefore, behaviors of y when x is between 1 and 3, the function graph is increasing negatively from minus 4 to 0. Question number 5. When y equals 0, when y equals 0, that is indicating the roots. Therefore, the roots are minus 1 and plus 3. Even you can get that from the equation here, minus 1 and plus 3. Anyhow, the roots are x equal minus 1 or x equal 3. Question number 6. What is the range of x? In which interval values of x does the function is negative? Here, this is what the negative part of the graph. What is the range of x? Here x value is minus 1. Here x value is plus 3. So, the negative part of the graph lies between minus 1 and plus 3. Therefore, function is negative between minus 1 and plus 3. Okay, let's go for one more question of the pattern equation y equal x plus a into x plus b. Support seminar 2017. The specialty of this year is the graph is given. The students no need to prepare the table or draw the graph. By observing the given graph, they need to answer the question. Okay, let's see the graph. And this is what the graph given. The graph of a quadratic function drawn on the interval from minus 4 to plus 2 is shown here. By using the graph, let's try to answer the questions. Question number 1. Find the value of y when x equal minus 2. When x equal minus 2, the graph indicate the value of y is minus 3. Therefore, when x equal minus 2, y value is minus 3. Question number 2. Write the equation of the axis of symmetry. And you know, when the axis of symmetry is drawn, it goes through the value of minus 1 of x-axis. Therefore, axis of symmetry is x equal minus 1. Question number 3. Express the quadratic function in the form x plus a into x plus b. Students, you know, the roots of the function are minus 3 and plus 1. If one root is minus 3 and it comes inside the bracket plus 3, the other root is plus 1, then it comes inside the bracket as minus 1. Therefore, the roots are minus 3 and plus 1. So the form of the function y equal x plus 3 into x minus 1. Question number 4. Very important question. Write the interval values of x which the function is decreasing and between minus 4 and 0. Here, this is what the range in the y-axis between 0 and minus 4. Within this range, which part of the graph here we need to consider? Within this range, they mention here decreasing part. Here the blue color part of the graph shows decreasing part within the given range of y. Within the given range of y, the blue color part shows the decreasing. Therefore, what is the interval values of x? So when you consider this blue color part, the x range here between minus 3 and minus 1. The blue color part of the graph lies within the range of x, minus 3 and minus 1. So when you are writing the answer, the x interval is going to be between minus 3 and minus 1. But one thing to be considered here, there is an equal sign in the given range. It comes along with 0. Y less than or equal 0. Therefore, when you consider the y value 0, the corresponding x value is minus 3. Y equals 0, the corresponding x value of 0 is minus 3. Therefore, when y equals 0, the x answer is minus 3. So, only 0 having this equal sign, so we are including that equal sign to the corresponding x value minus 3. Therefore, minus 3 less than or equal x less than minus 1. Question number 5. If the value of root 3 can be obtained from the intersection of the line y equal mx and the above graph, find the value of m. Here, intersecting point of the graph y equal mx and the quadratic function. Let's assume that this is what the graph y equal mx which goes through the origin, and this is what the intersecting places. Let's consider only this point. Here the intersecting point of the both graphs, you know that the y values and x values of the both functions are equal. When two graphs intersect at a point, the coordinates of the both functions are same, equal. The y value equal, also the x value is equal. Since the y value is equal of the both graphs, y equal mx, y equal x plus 3 into x minus 1, equalize the y values. Therefore, we can get the equation mx equal x plus 3 into x minus 1. To find the value of m, we need to substitute for x. Therefore, let's substitute square root 3 for x. When you substituted square root 3 for x, then let's simplify. After removing the bracket, we'll get this. And when plus 3 and minus 3 simplified, square root 3m equal 2 root 3. Once again, both sides divide by square root 3. M equal 2. M equal 2 mean the slant or the gradient of the straight line is 2. If you are drawing a straight line with the gradient 2, we can determine the value of square root 3. Anyhow, the method of finding value of m is equalizing the y value. Thereafter, substitute the given square root value for x and you can determine the value of m.